Thoughts on 1.7? If I saw this in the homework, it says let f of x equals 3 radical x. If g of x is the graph of f of x shifted down 5 units and 1 unit to the right, then we got to figure out a way to write g of x. And so g of x, if I describe it, first off, I know that f of x starts out as a 3 radical x. So we'll remember that it's a 3 and then a radical and then some kind of an x thing going on. If it's shifted down 5 units, that's easy enough. Up and down stuff means it happens after the function. So I wouldn't put it like in the radical, but that means a minus 5 after the fact. So that means down 5, like we had probably talked about in class. And then right 1 unit, that means if it's over to the right 1 unit, that's like a positive 1 thing. But you might remember when we're putting functions on the inside, messing with the x values, it normally looks the opposite of what it is, because if I put a minus 1, x minus 1 on there, then we're looking for that new 0, and that means the new 0 then is positive 1, like they're talking about, to the right one. So positive 1 minus 1 makes the 0 on the inside. Anyway, that's what I would do with something like this. Seems about right. Next one, similar idea. We have the graph of the function y equals f of x plus 34, and we're saying that can be taken from or obtained from the standard, the beginning function f of x. And we're just wondering what had happened here to get from f of x to x plus 34. But if it's plus 34 on the inside, remember, inside stuff messes with x values, and it's always kind of the opposite of what it looks like. So if we're looking for new 0 in there, negative 34 is the new 0. Because negative 34 plus 34 would make f of 0, and it would be good. So let's see here. That means negative 34 is our left and right part of the start point, so we must be moving to the left. So let's see if something describes that. Let's see here, 34, upward, downward, to the left. There it is. Left hand, 34 units. Ba-bam. What else? Oh, this is interesting. Okay. So now number 6, I see a table that's got, it's this f of x versus g of x thing. And so if we start out with f of x and it's got these inputs and outputs here, it's negative 2, 1, 0, 1, 2, and then blah, 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 blah. What I noticed about this, guys, is that in g of x, the new function, so f of x is the starting function, and then g of x is like the second one. And so if I'm looking for changes from the first one to the second one, what happened from f to g? It seems like the f of x part, the outputs, is the same thing both times. It's negative 3, negative 1, negative 2, and then g of x has the same outputs, negative 3, negative 1, negative 2. So the y values, the outputs are not different. Because remember, f of x is like y on the graph, and same with g of x. So those the outputs are the same. So this must be a difference in the x's. So let's see here. In the x's, it seems like it's negative 2 became a negative 1 became a 0, and then 0 became a positive 1, and 1 became a 2. And so it seems like this g of x is going, the x's are going up by 1. But remember, we're talking x's, those are inputs here. That's a left and right movement. And so those are always, that's on the inside of the function. So remember, when we're talking about this stuff, g of x will be described by, if it's on the inside of the function, the x values that are moving, it'll be something like g of x is, and then we'd be like something about f of, and then it'd be like x plus or minus something on the inside here, not after the fact. Because that, if I did plus or minus after the f of x thing, then that's an up and down movement with the y values. So we know it's an x plus or minus something on the inside of the function. And what I'm seeing here is that it looks like to get from f to g, we're plussing everything by 1. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. But remember, with the inside function stuff, with the left and right movement, it's always the opposite of what it looks like because we're looking for that new 0. So we would say something like this must be x, and then minus 1, opposite of what it looked like since it was plussing 1, because that way it's a positive 1, the plus 1 that it takes, that when I minus 1, it's like doing f of 0 again. It's our new start point on the x-axis. So I'm betting that, looking like we found it here. That's good. And then a similar deal for the second part of that. This is still number 6, but now it's another alteration of f of x. It's h of x is a new function, and we're looking at this one. It seems like this time, -2, -1, 0, -2, -1, 0. It looks like the inputs are the same. It's the outputs that'll be different. So this will be, if it's the outputs of the y values that are different, then we're looking at like f of x is like an up and down shift, because that's what y values do. But it'll be like f of x, h of x will be something like, it'll be equal to, sorry about the notation there, equals f of x like plus or minus some number after I do the f of x thing, some number there, you know? And so let's look at that. How much did it change? We have -3 and -1 and stuff. This one is -2 and 0. So it looks like this is also just up 1. If we started at -3 before, now we're at -2, and then we're at -1, and now it's 0. These are all +1 from the other one. So it seems to me like that's a +1 thing, but since it's a y value deal and output afterwards, then we don't have to do the whole opposite new 0 thing. So I'm betting that this looks something like f of x, and then like +1, I guess, you know? And so that's there somewhere. Yeah, there it is. Boom. Looking good. What else? Oh, I wanted to talk to you about this. Okay, number 9. Given f of x is x squared, that's the parent function. After performing some transformations, here we check this out. So we have shift up 68 units, and then it's here, shift 19 units to the right, it says. So up 68 and 19 to the right, and so let's make sure we have that working. So this one, new g of x will be equal to, it'll look like x squared, but it'll be, we're going to have to mess with this thing. So up 68 units is easy enough. It'll be something squared, we know that, because it looks like x squared, and there'll be some kind of an x involved. But then if it's up 68 units, that means just do a plus 68 afterwards, I guess. And then, let's see here, 19 to the right. So 19 units to the right on the inside always looks like the opposite of what you think it is. So it's really going to be a minus 19, because that's how you get that positive 19 to the right to make it like a 0, so you're at your start point again. Looking good. That's about all I think we need there. Number 10, I'm looking at this as an absolute value looking function. And that's why, I mean, this is a multiple choice one. The next one, some of them are not, you know. But I figured I'd at least talk about number 10 because it'll set the stage for the others. So this one is a multiple choice one, but whatever. We have absolute value function because it's all V looking. And I got to figure out how in the world this is going to go. And so it doesn't look like they messed with the slope or anything. I don't think we do that at this point in the unit, but it's still definitely not starting at 0, 0 like a standard absolute value function would, you know. They normally look like this, I guess. This one, we are down 2 steps and then to the left 3 steps. So we'll play the same kind of game as we did on the last question. So we'll say it's going to look like f of x or whatever, or y, it'll look like absolute value of x. It'll look like that. It'll look something like here. It'll look like this kind of thing. But we got to mess with it by putting pluses and minuses in there and outside of there to make sure that it goes up and down, left and right. So this one being down 2, it looks like we'll have an absolute value function. If it's 2 steps down like that, I'm going to go down 2, minus 2 after the function. But then the x values, the left and rightness of it, we mess with on the inside. So we'll say x, and then that's 3 steps to the left, or -3. And so remember, that's always playing the opposites game on the inside. So -3 is like +3. Because then -3 plus the 3 makes our start point, or makes our 0 on the inside. New 0 we call it, or I call it. And so then I'm looking at +3 and then -2. It looks like we found what we wanted. And these are similar. Okay. What else? Oh, this is weird. So on number 12, it's the first time we're messing with reflections here. And so we have the standard graph of y equals radical x. They even drew it for us. That's good. We don't have to get to know a new parent function. That's the parent function, and we got to figure out like how do we describe the following transformations. And so this next one looks the same thing. It hasn't moved any. We didn't translate it or whatever, but it looks like it's been flipped. You know, so it flipped up and down wise. They say reflected over the x-axis. It flipped up and down wise, and if it's an up and down movement, That's like a y value thing that's being messed with. And that means, once again, even though this is not a translation like moving things, it's flipping, it means that if it's an up and down movement, it's happening like after the function. And so it won't be something like radical and then we'll be messing with the inside of it. It's nothing like that. It'll still be, we're starting with y equals radical x, so it'll still look like that. It'll still look like radical x and then plus or minus something afterwards, except now we're dealing with timesing. So we're going to be timesing something, but not on the inside of the radical. It'll be timesing on the outside of the radical. You could do it on the right as well if you want. We just normally do it on the left. And so this one being a perfect flip, what I'm thinking there is that this is just a times -1 because it looks the same thing, it's just upside down, so it's not growing faster or anything. And so I'm thinking that'll be just a -1 version of it, so I'm thinking, look, something like this. This would be just radical x times a minus on the outside, or even a -1 on the outside would be fine. Timesing with it. That way every output you get, you just take the same thing, but then you'd be like times -1. Times -1, times -1, and it flips it all downstairs on the y values. This one is similar, but it's a different flip. This one's a left and right flip, so the original one looked like over here, and this one's going this way. And so that's an x value flip, and remember, things, if it's a flip, it's more of like just putting a negative somewhere, a -1 somewhere. But since it's on the inside, that's an x value flip, or what did I just say? I don't know. Since it's to the left-hand side, it's a left and right flip, but that means it's on the inside of the function. And so in this case, we'll say, well, it's a radical x, but we're going to flip it inside, messing with our x values instead of the y values that come out afterwards. We'll mess with the x values before we even radicalize it. And you could put -1 radical, or -1x if you like, or just -x is fine. That looks pretty good. Okay. Something else weird here. This is what we're talking about. So number 15. We got this picture, and I guess we just have to describe it. It looks like, I mean, as they'll admit to you, it's an f of x equals, it's like an x squared function. But this one's upside down for one, and it's moved. And so we'll use the same routine as usual. This thing starting there instead of at the origin is 2 steps up. So it'll be something to do with, like, we'll put a +2 after the fact. So some kind of an x thing going on, and it's squared. It's a +2 after the fact because that's the up and down part. And then it's 3 steps to the left, so we'll pull that same trick as before because we'll be like, well, it's a -3, so I need a +3 because of the whole new 0 thing. So it's always opposite on the inside, right? And then the fact that it's flipped upside down is just like we were doing on the last one. So we're going to have to say, well, if it's flipping up and down wise, I'm going to have to shoot in a negative like before or outside of the function. It won't be a negative on the inside here. And so we can just to even put a negative there, and then that should take care of it. Negative, and then the parentheses, or you could put a -1 or something like that. But that's probably what they're looking for. And so something like that should work. Let's see here. That'll be negative of x plus 3, and then +2, looking pretty good. And again, you can put a -1 there if you like. Wanted to talk about this too. It's a little bit weird. Number 16, they describe a function g in terms of f. If g is taken from, let's see here, it's obtained by, what did you do? You reflected f about the x-axis. Okay, so we reflected the graph of f about the x-axis, so that's an up and down flip. And then it's being horizontally stretched by a factor of 2, and that's something we haven't really talked about, and so that's a little bit weird. Horizontal is left and right, though, remember. That's an x value thing. And so remember, horizontal stuff is always on the inside when we're messing with our x's before we even do f of anything. And so it's probably we're going to focus on that. So that being the case, let's look at this. It says, I don't see it, anything, okay, so this thing has a +c, they're saying put it in this format, we'll talk about that, but I don't think there's any plus or minus going on here, because all I see is this thing being reflected or, flipped, and then horizontally stretched. So let's see how that works, and I don't think we'll have room for a plus anything, because that's when you're moving them around, translating them, we call it. And so let's see how that goes. Well, let's just start from scratch. G of x equals, and then if I were to take f of x and I flipped it across the x-axis, that's an up and down flip. So that would be outside of the function flip. So this would be f of x, not putting the negative inside, but on the outside. So it's a negative f of x, or a minus 1 if you want to, times f of x. That's what that says, minus 1, I don't know, whatever. And then it's stretched by a factor of 2, but that's a horizontal stretch. And so this is something we haven't talked about a whole lot, but just the same as when we're dealing with a left and right translation, if it's on a horizontal issue, it has to do with the x's, and we'll have to mess with our x's before we even take f of anything, before we run it through the function. But as usual, since this is a timing thing, they're talking about a stretching factor or something like that. As usual, though, the x value stuff is always opposite of what you think it's going to be. So without over-explaining things, you would think that this would mean like x times 2, because it's stretching twice as big, but when you're messing with your x's ahead of time on the horizontal end of things, it's always opposite of what you think. So it's really divide by 2. So we say times a half instead, or 1 over 2. And if it had been like by a factor of 3, then we would have done 1 over 3, etc. Anyway, that's all I see. I don't see it doing any plus or minuses, so we can do plus 0 basically if we wanted to make it look like the answer was asking for. Anyway, so that means we have negative 1 times f of a half x plus basically nothing extra. So if I were to fill in that stuff, that means like, I guess the a part is 1, the b part is a half, and the c part is nothing. And so let's see here. A part we said was negative 1 to flip it. B part was compress it, and so, or stretch it or something, right? Yeah, we stretched it, and that's why it was at 1 over 2. And then C is nothing because we didn't plus anything on there. That's what I think about that one. 17 will be similar, but maybe not as difficult in the version that I saw. I don't know. And then, oh, here's something weird. Okay. If I were to compare these two functions, on number 18, it says, we have, this picture given. It doesn't even say what function it is. It looks like just some kind of a pair of linear functions put together. It's whatever, but it seems like it goes up as high as 1 and down as high as negative 2. So that's worth noting. It has this kind of a downhill look to it. And then, if we need to analyze it, it goes as far as left and right go. It goes over to 1 and then over to the right as far as 3, and we're going to see how this one is different. What I notice about it is that both of them are centered in the same place. They're both centered at like this O2 point. And so it doesn't look like there's any like translating going on. We're not moving the function, but it does look like there's some kind of a flipping, growing, stretching thing going on. So we got to figure out what that is. And so first off, you might notice this one was downhill, and the new one is kind of going uphill, and that's weird. So we should talk about that. And so that's a vertical flip. So if nothing else, as we're starting to think about this stuff, we could say, well, if that's f of x, then we'll call this new one g of x, right? The g of x looks like it's been flipped as well as grown, because this one obviously goes way up higher and lower than the other one did, and so whatever. But we'll say, first off, it flipped upside down, and so that's a negative 1 times of f of x again. Negative 1 will flip it upside down, so that would have made our old picture look a little bit more like this or something, and it would have flipped it upside down. Here's the thing, though. If we put that flipped, and that was all we did, then this is what it would look like compared to the new graph. We would like, okay, so it's flipped. And then I think it looks like this. It would go up to 2 and down to negative 1 instead of before it was up to positive 1 and down to negative 2. But this thing has been stretched upward too, so it's twice as tall. I don't see any difference on the left and rightness of it. Like if you look at old function and new function, they both stop and start. As far as left and rights go, it's still going from 1 to 3. So they don't think we're messing with the x values. We're probably just messing with the y values. And so let's see here, y values here, we'll go, it was up to 2, now it's up to 4, so it looks like twice as tall, I guess. And let's see here, this was down to 1, and this is now down to 2, so it's twice as tall. Yeah, indeed. So then we'll just have to make sure that as we account for this, not only did we flip it, but it got twice as tall. So when I times it by a negative, it was good to flip, but it's a negative 1 isn't big enough. We're going to have to say, let's times it by negative 2. so that not only is it flipped from the negative, but it's twice as tall from the 2 times f of x. Looking good, and I think that's all that's going on with this one. There's no horizontal stretching going on. It's not further to the right or to the left than it used to be, so that'll work. So let's see, if we got a equals and b equals, they're talking about like formatting it that way. You'll remember we times the a part was like a -2, and so we'll put -2, and then the b part, we didn't times anything on the inside of this because there was no left and right adjustment. So we just call that a 1 because it'll still be a 1x on the inside. That's looking pretty good. Cool. Last little bit wanted to talk to you guys about. Check this out. Okay. So in 23, this one's particularly weird. If 1, 3 is a point on the graph of f of x, which of the following ordered pairs must also be on the graph of this new thing? And so what we have is this new thing. It's not, you could call it g of x if you like, but it's, what it is a new function. It's defined as it's y equals, and it has f of something in there, but it's not f of x, it's f of x take away 5. It's like a translation, it's a transformation of f, and so it's like, we got to figure out how these two are related. And what's interesting about this is we're not given much info at all. Hey, wiggle camera. So I guess we'll just kind of extract as much as we can from the 1, 3 thing. So one thing that comes to mind is we're looking at this. If we're saying that 1, 3 is on the graph of f of x, what comes to mind for me, if I think about that in terms of x's and y's and like inputs and outputs, another way of saying 1, 3 is to say that f of 1 is equal to 3, And so if we say f of 1 is equal to 3, and we're supposed to relate that to this over here, the best I could come up with is to say, well, if we could just craft a number that would relate this over there, like if I put the right number in here, something minus 5 would become a 1, and then I would still have an f of 1 thing there. And so that'll be the dream. We're going to hope to dream for f of 1 to come out of this. And so I just got to plug the right number in for x. That would make the insides here be like a 1. And so what comes to mind